Okay, again, in the last video I made, I forgot to mention about conservation of linear momentum, conservation of angular momentum, of angular momentum. So I'll just say it now before I go into what I intend doing today. So um conser linear conservation of angular momentum. Angular momentum is conserved. That's just what I want to say. Angular momentum is conserved when the net external torque acting on a system is zero. That is when the total external torque acting on a system is equal to zero, then the total angular momentum on that system is constant, or it is zero. That is summation, the total torque, okay, which is equal to dl dt. Now, if the if this is zero, then it means that the LDT will be zero as well. So which means, therefore, L, angular momentum, is constant or conserved. Now, what kind of scenario can we think of? Let's say we have a circular object, okay? A circular object, sorry. And a force is applied at this point, okay? And another one is applied downwards like that. So if these forces are equal, okay, you know, each force independently, each single force, let's call this F1, F2. So if F1 acts without F2, this is what I mean. If there is no F2 here, this force will tend to give this object a torque. It's going to give it a torque, and this object is going to rotate in that direction, in an anti-clockwise direction. If it is acting alone. And if the other force as well acts alone too, F2, if F2 also acts alone without F1, it's also going to give this a torque in this direction. Now, if F1 is equal to F2, then it means that the total, the net torque, the net external force or net external torque on this object is going to be constant. It's going to be zero because they're going to counterbalance each other. Like they're going to balance each other out or cancel each other out. This one, they're acting together. This one trying to rotate this body in this direction and this trying to rotate it in the other direction. And they are equal. They will definitely balance each other out. And this body will not move. It will not rotate. So this is a situation of where total angular momentum is conserved. Okay. So I forgot to mention that in the last video. So I'm putting that here. So this is the expression that shows that when total torque is zero, then angular momentum is conserved. All right, now let me go on to today's business, equilibrium. Equilibrium, statics, and elasticity. Equilibrium, statics, and elasticity. Conditions for equilibrium. I believe from our school days, secondary school, we have learned about conditions for equilibrium. A particle is in equilibrium, okay? A particle is in equilibrium. Sorry, So a particle is in equilibrium when it does not accelerate, when there is no unbalanced force acting on it. A particle is in equilibrium when it doesn't accelerate. Particle is in equilibrium when it doesn't accelerate. Okay? Or when the vector sum of all the forces acting on it is 0. Or when the vector sum of all the forces acting on it is 0. So which means sum of all the forces is 0. But for an elastic material to be in equilibrium, elastic material in equilibrium, then its center of mass must have 0 acceleration. For an elastic material to be in equilibrium, its center of mass must have 0 acceleration. Now, what causes objects to accelerate? What makes objects accelerate is when there is an unequal force acting on it. That is, maybe one force is greater than the other. For example, if someone is pushing you backward and another person is pushing you forward, like a small child trying to push you backward and an elderly, someone stronger trying to push you forward, there is no way the elderly person is going to overpower the younger child. So you would accelerate forward. Acceleration happens when there is unbalanced force acting on an object. So for an elastic material to be in equilibrium, then its center of mass must have 0 acceleration. That is, the vector sum of all external forces acting on that body in all directions, like for now, we're going to take the XYZ direction, must be 0. So this is the first condition for equilibrium for bodies. First condition of equilibrium for bodies, which I'm sure you have learned in school. Sum of all forces acting on a body must be 0. The sum of all the forces acting on a body must be 0 under equilibrium of forces. I think moments of the force. I think somewhere there, if you go check your textbook, you will see that. So you need to read up. So go to your textbook and read it up. So the first condition for equilibrium is that the center of mass must have 0 acceleration, or we can say the vector sum of all the external forces acting in XYZ direction must be 0. And this is the first condition for equilibrium. So you might want to write that down. First condition for equilibrium for a body. First condition for equilibrium. Now, please do not be confused when I'm mentioning elastic and I'm mentioning body. All bodies have a degree of elasticity. At this level, I want you to discard the thinking that it is only rubber materials or plastic materials that are elastic. All bodies have a degree of elasticity. Everything expands or contracts. It might just be in very tiny amounts, but everything over time expands or contracts. Okay? So when I'm talking about elastic bodies here, I'm talking about bodies in general. Okay, so first condition for equilibrium of a body is that the vector sum of all external forces acting in X, Y, Z direction must be 0. Full stop. So this is the first condition, and that is writing it out, the summation of F equals 0. That is breaking it down in the X, Y, Z direction equals 0. Summation of F in Y direction equals 0. And the summation of F in Z direction equals 0 as well. Now, the second condition for equilibrium for a body or an elastic material is that the body must not have the tendency to rotate. That is, the torque, the sum of all torque, external torque acting on the body must be 0. This is the second condition. The sum of all the external torque acting on the body must be 0. So you might want to write that down. Second condition for equilibrium is that the sum of all the external torque acting on the body must be 0. If you want to put it in another way, you can say that the body must not have the tendency to rotate. So those are the two conditions for equilibrium of elastic materials or bodies in general. Now we look at center of gravity. From center of gravity is that point on the body where the weight appears to act. This is from secondary school. We understand that the center of gravity of a body, or we can say the center of the gravity of the body, is where the body is going to balance. Okay, if you try to balance an object, wherever the point where it balances will be its center of gravity. So the weight of a body is assumed to be concentrated at the center of gravity. The weight of objects, center of gravity, CG. So the center of gravity of objects is concentrated at a point where it appears all the weight of that object acts. We can ignore that acceleration due to gravity. Now, if we want to determine the center of gravity, hold on.
Minority in a majority black country. That's also a fact. Ladies and gentlemen, if a white president ever wants to exist in South Africa, he would have to do what no white politician has ever